So today we're going to talk about the functions of blood as a whole and then look at two of the cells that are in blood. We'll focus more on the red blood cells tomorrow because there's a lot more things I want to say about them, even though they're rather simple. But let's start here at the top with the functions of blood. First one, I'll spot you. Transport nutrients, wastes from the cells, and dissolved gases. Examples of dissolved gases would be what?
Carbon dioxide.
CO2 and oxygen. Okay. Nutrients from your digestive system absorbed there, wastes from the cells to get rid of, basically transportation. But there are 4 more things that your blood does. Like what? All right. That's okay. If you knew everything, I wouldn't have a job. All right. Regulate. Did I spell functions? Oh my gosh. That's because they're fun.
Yeah. It's not funky, it's just fun.
Oh boy. I'm glad I chose to record this session. Will that work?
Yeah.
Functions of blood. Because Helly is dysfunctional. All right.
Regular.
Yep, that's it. Number 3. Just regular today. I'm feeling regular. Had plenty of fiber. All right. Okay, what this should be is regulate body temperature. Your blood warms you and it cools you. If you're getting too warm, your body will send your blood to the surface of your skin to cool. If you're getting too cool, your body will take the blood away from the surface of your skin and constrict those capillaries at the surface to try to conserve the heat. Anything I misspelled on those 2 lines?
I think you're good.
All right, good. Keep tabs though. All right.
I will.
All right. Next one is to restrict fluid loss. At injury sites. In other words, I'm saying clotting. To make sure that we don't bleed out and stuff. Now this next one is primarily the function of the white blood cells. Now what's that? Yep. It's to fight disease. And the last one is a little less intuitive, harder to pick up on probably, but it's super important. It regulates the pH and electrolyte composition of the body. Now, in the textbook it says of the interstitial fluids. Well, interstitial fluid is a term that means the fluid in between the cells. And whatever the fluid in between the cells, pH, is going to be ultimately is what the fluid inside the cells is going to be, which is basically then everything. So it regulates the pH and electrolyte composition of the body. Do you guys know what the pH of blood is?
7 point something.
7 point something, yes.
3.
Boy, you're close.
4.
7.4. That's the magic number. But it's in flux constantly around there. Here's the range that you can still live through. 7.35 to 7.45. And that's not much of a range because your body doesn't afford that much of a range, which is why it's really, really important what kind of medications and so on and so forth that you take, because some of them can cause the blood to go into acidosis, which can denature your enzymes and slowly kill you. Yeah. So it's really important to to know what it is that you put into your body as far as medications and whatnot.
So if your pH goes like 7.2 for a little bit, will you die?
Well, the thing is, for a little bit, is how would it get to that? And your body wouldn't be able to reverse that in a little bit. That's why a lot of medications you do have to take orally, and you can't take an IV, and that's why IV fluids are really specific to what their pH is and so on and so forth as well, because yeah, that can really mess things up. Yep. Because those enzymes that are in our cells, the proteins that are folded up to do a job, they're dependent on this range to work. Now, this is not to say this is the range of the whole body, because the pH of your stomach is between 0 and 2. But it's not considered the internal environment of the body, for reasons we'll explain a little later on. Okay, cells of the blood explained. Actually, no, expanded. All right, so here is this one, round, kind of weird looking, not perfect on the ends. Put a bunch of little spikes on them. Make sure he gets a nice big nucleus there. And this is the only cell in your bloodstream that has a nucleus. Which cell is this? It's the white blood cell. White blood cell also has the name leukocyte. Leukocyte. The suffix here, "cyte," simply means cell. So if you encounter that, anything that ends in "cyte," that's what it means. Leuko, what do you think it means? It means white. All right. Some important features about this cell here. Here's some selling points. Has a nucleus. And DNA and such. Okay. And that its job is to fight disease through a specific process. Fights disease through phagocytosis. Phagocytosis, which means basically eats stuff. So basically, if it's fighting an infection, it's eating that thing. If it's fighting bacteria, it's devouring, digesting, and recycling the nutrients of that. So it engulfs whatever it's fighting. And it's a lot of times the antibodies that tell it what to eat. Antibodies go through the bloodstream and they paint foreign invaders. These things come around looking for things that are covered with antibodies. They're like, oh, I'll eat that then. All right, now I'm going to put a range on here. From here to here. So this little section be normal. Right? Okay. Here's too few. Here's too many. All right? So, over here, too few. If you have too few white blood cells, it's difficult to fight disease. Lots of things can cause this. Chemotherapy and so on and so forth. Anything that kills cells has the potential to kill in white blood cells and make it difficult to fight. Range normal is good. We're going to go up to here, though, slightly more than normal from here to here. And I'm not going to give you any quantities on here because I don't want you to worry about memorizing numbers here. But slightly more than normal, okay? This is when you're fighting an infection. Often they will take a blood sample if they don't know what's wrong with you and see what your white blood cell count is. If it's amplified, it means that your body is in the process of fighting an infection because the body is efficient / lazy, okay? You don't want to make more cells than you need because you have hungry mouths to feed, okay? If you have too many white blood cells, they're going to sap your resources and you have to feed them. The good news about when you have them fighting an infection is bacteria is reproducing. So the bad guys are actually creating something for them to eat. So no problem there, okay? But that's why you don't keep an abnormally large supply of white blood cells at the ready, but your body will ramp up production of them in the process of an infection. Now this range here is where if you have way too many, okay, this is leukemia. Okay. Now, it's not to say that, fighting an infection can turn into leukemia. That's not what I'm saying. I'm saying that if you have way too many outside of the range of normal, that means that it's likely the result of leukemia. Leukemia is cancer of the blood. Now, it's not so much the quantity of cells that are an issue with cancer is that, number one, they can't control the rate at which they're dividing. And two, the cells that are being produced are not functioning well. It's not like this person would be really super good at fighting disease and infections because these cells are not working like they should. So this is also why people lose a lot of weight and things like that with cancer, because it takes a tremendous amount of resources to be able to feed all of these abnormal cells even though they're not doing a job. Okay, so that's the range here. Normal is this little section here in the middle. If you're fighting an infection, it'd be slightly more than normal. Difficult with too little. And then beyond this normal range, then the condition for this right here, more than normal, is called leukocytosis. Okay, leukocytosis. If it's way too much leukocytosis, then it's probably cancer. Okay. Now, the next cell, and the last one we're going to look at today, are platelets. What's the first thing you notice about these platelets? They're very small. Yeah, they're about 1/20th the size of a red blood cell or white blood cell. Platelets. Now, platelets aren't distinguished by color. They're really nothing particularly colorful about them, so they don't refer to color on here. They're called thrombocytes. Again, cyte means what again? It means cell. Thrombo is a prefix that simply means clot. Okay, so these are basically clot cells, and that's what they do. They have no nucleus. They're about 1/20th the size of a red blood cell. They're really small. Okay. They combine with proteins in the plasma to clot. And again, we're going to make another range here.
What's the size of the white blood cells?
Aren't
they like bigger than red?
They're a little bit bigger than red, yeah. But they can't be too terribly much bigger because they still have to float through these really small capillaries and so on and so forth. So they got to squish through those spaces. So there's kind of an upper limit for how big a cell can be if it's flowing through the bloodstream. Okay. Okay, there's a pretty good size range of normal here. Okay. And then if there's too few over here, too many over here. Now, this is a sliding scale, and it's somewhat relative because what's normal for you might be too high for someone in their 70s. Let me explain why. Let's start over here on this side. Having too few makes it hard to clot. Okay? And if it's hard to clot, what's that condition called?
That's when you just bleed out.
Yep.
Yeah, when you get a
Hemoglobin.
Hemophilia, which is kind of a weird misnomer. What does hemo mean? That prefix means blood. Now, philia comes from the Greek. It's one of their words for love. They have 3 words for love, from my knowledge. They have eros, which is erotic love. They have philia, which is philios, which is brotherly love, and then they have agape, which is like a God love. And then philia means to love. Well, I will tell you, someone with hemophilia does not love the sight of their own blood. It's not good at all. Okay? It means they can't clot properly. So it's kind of a misnomer how that term came to be.
I think it's a vampire loves your blood, so like you just bleed out for him.
Oh, thanks for that. All right. So, gang, on this right here, like I said, you can't count on these word roots. A lot of times they're pretty good, but sometimes they'll be a little confusing. But it's not always the cells either. Sometimes the genetic factors that cause people to be have hemophilia will be related to the proteins in the plasma they can't produce as well. But if you don't have enough platelets, then you also can't clot. Let's move to the other side here. Okay, too many, there is risk of thrombus in blood, or clots in blood, which in the brain means what? What's that called if you have a clot in your brain? That is a stroke. Okay. In heart would be what? Heart attack. Okay. That's why a lot of older people, especially if they've had a heart attack, go on blood thinners. You see probably commercials for them on TV. You know, one they don't advertise for anymore is Coumadin. Coumadin is like the most commonly prescribed generic for blood thinner. And blood thinners is kind of a misnomer. It has nothing to do with the viscosity of your blood. It has everything to do with the quantity of platelets and how effective they are at bunching together. There was, I think, Plavix, and there was a few others that were, you know, and they come up with new ones all the time. Coumadin is actually warfarin. Warfarin is the main ingredient in rat poison. Yeah. So people are being prescribed rat poison at their pharmacy to combat heart attack and stroke. But the most common type of this, not actual rat poison, like it's actually, you know, prescribed in pills and stuff, but the over-the-counter version of this, they found that aspirin is a tremendous blood thinner as well. It keeps your blood from clotting. And so someone can start a daily regimen of aspirin to control basically the stickiness of their platelets and so on and so forth. So that's our functions of blood, and the first 2 types of cells we'll discuss: white blood cells and platelets.